Hi everyone, I hope everyone had a nice week. We learned a lot of things, a lot of different functions, different parts of coding, but most important thing you have to remember is that coding is not just about computer, it's not about just like writing programs, but it can be used every day in our lives, in different subjects, in different places, because it's all about logical thinking. So I really hope and I urge you to always to think logically whenever you approach a problem so you can solve them in a very effective way. Okay. So today, and as our last topic, we'll review a loop and we're going to talk about nested loops. We're going to do some exercises and then our last activity in MakeIt. So loops review. So we talked about we said there are three types of loops. One is counting, one is conditional, and counting loops usually is referred to as, or we usually call them as for loop. I forgot to mention the last time, for, like the word for, for. And conditional loop is usually referred as while loop, like while something's happening. So it makes sense because why? When we say for, we for how many times you repeat such thing. And while some condition is true, repeat something, okay? So remember that, okay? Counting loops, for loop, conditional loops, we call this while loop. Now, infinite loop is very dangerous because if computer goes into infinite loop, that means it's been, it can't do anything else. It's like just looping infinitely. So if you've been using PC, you might have encountered something called the blue screen of death. And usually this is what's happening. Something is in the loop and it's not working correctly. But anyway, the main idea of all this loops is that a loop repeats a pattern. So two important things when you're dealing with loops. Number one, you have to be able to know what pattern is being repeated. And number two is what condition, like do we know the parameter, do we know the constraint for how many times or what condition this pattern has to repeat, okay? So anyway, what is nested loops? Nested loop is just loop within a loop, okay? So when you're looping through something, within inside, there's looping, another looping, okay? Now this nested loop does not have to be one level. It doesn't have to be two level. It can be multiple levels, but it can get really dangerous if you go more and more in depth, okay? Now, so you can think of nested loops as pattern of patterns, okay? Because it will loop within a loop. And believe it or not, you can encounter a lot of things in nested loops in our lives. For example, cleaning, eating, and different things. So for now, just think about what might be nested loops that we see everyday lives. And when you're done thinking, let's go to our example, cleaning. So for example, let's say we're cleaning your house, okay? Let's say there's 5 different rooms. It doesn't have to be rooms, it can be places like living room, kitchen, bathroom, whatever, okay? Doesn't really matter. And your job is to vacuum them, okay? So how might we make block code that accomplish this task? So the first thing is you need to go to a room, right? A new room, and you want to vacuum the place. And once you're done vacuuming, you want to get out and you repeat this for 5 different places, right? So first, this vacuum process has to be done not just one time, but it has to be repeated, right? But you don't really know how many times you have to vacuum. So we can make a loop here, not counting loop, maybe conditional loop, like while the room is not clean, meaning repeat or process this action when the room is not clean. Because if the room is clean, why vacuum, right? So this will repeat until the room is clean. And when the room is cleaned, this will get out of the loop and go to other room. Now, once you go to the other room, right, or get out of the room, you need to enter a new room, right? So this is why you need another loop here. And this is for loop or counting loop because why? You exactly know how many times you repeat this. You want to repeat this 5 times. Now, of course, this is an example, okay? It doesn't really have to be this series of actions. It can be different, okay? But just know that this is one possible way we can block code our vacuuming, right? This loop is called outer loop because why? It's outside. It's like encapsulating what's in. And the inner loop is called inner loop, duh. and that is called nested loop. So when we say nested, it means it's embedded inside of something. Okay, and remember, there can be multiple nested loops. Now, next, exercise number 1. So let's say there are 6 broccolis on a plate, as you can see here, and your job is to write a block code that will allow you to eat 6 broccolis while chewing each one at least 5 times. Now, here's the given actions. There are 4 actions here: picking up, chewing, eating, swallowing, and there's this repeating function. So pause the video and come back once you're done. Welcome back. So maybe, hopefully, you did something like this. Like you need to pick up the broccoli, right? And you have to eat it, right? And after you're eating it, you have to chew, right? You have to chew, and then you swallow, right? So the chewing happens multiple times. We've seen this like last time, right? So for this example, I said we want to chew at least 5 times. So we need to think about that. And then we need to repeat this whole process. How many times? 6 times is what? There is 6 broccolis, right? So in this case, we say repeat this chewing process 5 times, right? After 5 times is gone, you swallow, right? And after swallowing, you have to pick up another broccoli and you repeat this how many times? 6 times. Now, is this the best way to describe this? I don't think so, because why? Do we really have to chew 5 times exactly? No. So better way might be changing this for loop into a while loop or conditional loop, so that we can say if the food is not broken down, right, you chew. But it's broken down enough, then what do? We swallow. Now, what about broccoli? Do we really have to eat everything? What if you're full? So you can say, while you're not full, you eat, right? So when we're doing loops, you have to think about not only the actions or patterns, you have to think about what constraint, what conditions do we put on the repeat so that it does what we really want to do. What does it, which one optimizes the process, okay? Moving on, exercise 2, you're playing a game where you draw 4 random cards out of a standard deck of cards. Whenever you draw a face card of Jack, Queen, King, or Queen, right, King, you must do 10 push-ups. Now, this is a silly game, yes, but the purpose is to write out a block code. So pause the video and think about how we might do this. I will welcome back. Solution. So this is one of the solutions we can do. So we can draw a card, and we have, I guess we have a if statement. If the card is face card, you push up 10 times. But if the card is not face card, do we process this action? No, we don't. We just skip and then repeat this process how many times? 4 times. Okay. Now this is a silly example, yes, but it contains things that we have learned. So I thought it was a good exercise. Okay, if you don't have your tablet or your smartphone ready, please go get them. And if you're ready, let's go learning as usual. And let's go to the Fusion Maker. And today we'll work on trash bin for lazy person, like myself. All right, trash bin for lazy person. So today we'll make a trash bin where you can open and close just by motion sensor. So what do we need today? Of course, we're going to need the board, the power cable, adapter, depending on what phone you have, breadboard, male-to-male jumper cable. We need ultrasonic sensor, and we have servo motor. This will move, rotate, depending on our code. So the ground will be attached to here, and the 5-volt will attach to this. Number does not really matter as long as you're consistent, but to know that ground is on one side and 5-volt is on another side. All right, and the ultrasonic sensor will be attached. The ground will be attached to the same row or same column as the ground from the original board, and the 5-volt VCC is in red, is attached to or connected to the same row as the 5-volt from the original board. And echo is attached to number 12 on the digital pin, And trigger will be attached to number 13 on the digital pin. Okay, keep that in mind. Oops. And the servo motor, the black wire is the ground part. The ground is attached to same row as the ground from the Arduino board, of course. And the middle one, which is the power source, VCC, will be connected to same row as the other VCC. And the last one, where the signal will be received, is attached to pin number 4 in the digital section. Okay, so refer to this when you're making this with me later on. Okay. All right, first task. So do the block coding so that when the Arduino board is turned on, rotate the servo motor by 90 degrees. Okay, let's try it. All right, let's zoom in a little bit so you all can see. So which block should we use? We should use this one. When it's turned on, we want the servo motor. Remember, we connected the servo motor to number 4 pin, right? So make sure you keep those numbers consistent and angle to be 90. So this is a default setting. When this is on, the motor will rotate or change. The angle of the motor will be at 90 degrees. Let's check the answer. There we go. Same answer. Moving on to number 2. So if the ultrasonic sensor is close to 10 centimeters, so if there's an object within 10 centimeters, rotate the motor by 150 degrees. I know it doesn't say it, but let's try to do 150 degrees. So now we want to be in forever. And of course, we're going to be needing if statement, right? If what? Well, less than 10 centimeters. So this will be 10 centimeters, right? And what sensor are we comparing with? We're comparing with ultrasonic sensor, right? Oops, maybe zoom out a little bit. Make sure the trig and echo are consistent with what we have. So let's just check. Trig 13, echo 12. So we're good. So when this is true, what do? We rotate the servo motor that is connected to number 4, angled at 150. This value can change, but let's set it to 150. All right, let's try to do a simulation with what we have. As you can see, as soon as it was turned on, it rotated 90 degrees. And watch. So when an object is more than 10 centimeters, it doesn't really move. But as an object gets near and gets within 10 centimeters, what happens? Watch the motor. It rotated to 150 degrees. You see that? And there we go. It opened. What next? Okay. So now, what we want to do is we want to wait 3 seconds after it's opened and close the lid by changing the angle to 5 degrees. So we want to wait 3 seconds, or was it 5 seconds? 5 seconds. And then you want to change the lid to 5 degrees. Now, of course, these values should change depending on what kind of trash bin you're thinking of creating. But for now, let's try to do simulation. All right, so let's try. All right, for now, let's do a simulation to see what's going on. All right, initial 90 degrees. And when an object is within 10 centimeters, it opens and tries to close after 5 seconds. Oh, what happened? The reason why it doesn't go all the way down is because this object is still within 10 centimeters. And watch. Try it again. Now it's above. It will close, which is what we want, right? Because if something is nearby, you want to keep the lid opened. So there we go. So now let's try to actually make this in real life. Let's go. First, we'll connect the Arduino board to the breadboard. 5V from the Arduino board to number 17 on breadboard. GND ground to number 16 on breadboard. Okay. The sensor will connect now. I will use a female red wire to connect to VCC pin on the sensor, a purple wire to connect to the triggers pin, also female, a blue wire to connect the echo, also female, and lastly the ground with a black wire to be consistent throughout. Now we'll connect these cables to the breadboard. So connect the VCC from sensor to number 17, which is connected to 5V from Arduino board. And the GND part to number 16 on the breadboard. And trigger pin to number 13 on Arduino board. And echo pin to number 12 on Arduino board. Now we're done connecting the sensor to the circuitry. Now it's time to connect the servo motor. I will use a male brown wire to connect to the ground GND, a red VCC wire, an orange wire will be used which will receive signals from Arduino board. Okay, I will keep the colors consistent so you can follow which is which. Okay, now let's connect this to the breadboard. VCC to number 17, which is the power, the positive side, and the black wire to number 16, which is ground or negative side. And lastly, we'll connect the orange wire to pin number 4 on Arduino board. And through this wire, a signal will be sent from the Arduino board to the servo motor. And we're done with the circuitry. As you can see, when a hand is near the sensor, the servo motor rotates, and after 5 seconds, it rotates back to close the lid, as we expected. And now we'll see some final products that people have made. Okay. At first, this trash bin opens up the lid using a string and closes as we expected. And the next uses cardboard box, straw, spoon to open up the lid. So these are some examples. Feel free to do and create your own depending on whatever things are available around you. Have fun!